In this unit, we'll be constructing angle bisectors. We've already constructed segment bisectors, and so this is for angles. One way to think about an angle bisector is to think about a softball field or a baseball field and where the pitcher's mound is located. That pitcher's mound has to be the same distance from the foul line, and we've talked about how the distance from a point to a line is the perpendicular. And so the same distance to the foul line here, the first base foul line, to this one. So those distances have to be the same. Same thing with second base to first base and second base to third base. Those distances have to be the same. So you know that the pitcher's mound and second base are going to be on that angle bisector. So if you think about how you could construct it, and we're not going to do it, I just want you to think about other opportunities or other ways that you can construct things. On patty paper, if you drew an angle using a straight edge, you could simply fold it over using the vertex as one of your points of your fold, and fold so the two rays meet, and then that fold line will be your nice perfect angle bisector. So that's all an angle bisector is, nothing real complex. So let's go ahead and try one with a compass and a straight edge. So with your straight edge, draw an angle, any angle you'd like. A cube might be a good one to start with. And I'm going to use my compass and turn it around here. And I'm going to open my compass to any measurement I really want. It doesn't matter. I'm going to put my compass on point on the vertex. And again, this measurement can be anything I want. So how about right there? I'm just going to intersect the rays of the sides of the angle in two places. So I needed these 2 points of intersection. And now I'll use my compass. I'll put the point of my compass on the point of intersection. And I want my compass opening. It really doesn't matter. I can change it again. But I want it to be able to overlap when I put the compass down here. So I'm going to go ahead and make an arc about right here and see if this works. This I have to keep the same. I'm going to move my compass to this point of intersection and copy that measurement. So here's my arc. I'll use my straight edge to connect a vertex to my point of intersection, and I should have two congruent angles. And so the distance from any point on here should be the same as the distance from the same point to the other side. So kind of like the pitcher's mound to the foul line, that's going to be the same as long as that's on the angle bisector. So if a point is on the angle bisector, then it is equidistant from the sides of the angle. And that way you know that you've done it. So let's try to create a 45-degree angle, thinking about bisecting angles. Let's start with something we know. I know how to create a 90-degree angle because I can draw or construct an angle, a segment bisector. So I'm going to bisect this segment. You could also draw a perpendicular from a point to a line, whichever method you'd like to choose. I'm going to open my compass to a little more than halfway, not like that. Open my compass to a little more than halfway and make an arc, and I will bring my compass point down to the other end of the segment and make an arc that intersects twice. And this should be a review. I'm going to use a straight edge to connect the 2 points of intersection. So I've got a nice right angle here. So I know that's 90 degrees. So if I combine that with the fact that now I know how to bisect an angle, I can put my points on my vertex, and I can choose any one of these 4 angles. I think I'll choose this one. I'm going to bring it in a little bit so I can see it. I'm also going to try to change my pen color. I think it'll work for me. Yeah. So I'm going to make an arc that intercepts those 2 rays of the 90-degree angle twice. I'm going to move my compass to this point of intersection. Make sure that it overlaps. At this point I could adjust it a bit, but this looks pretty good. I'm going to make an arc, and I'm going to bring it down to this point of intersection and just need that point of intersection, which I got. Grab my straight edge, go from my vertex to the point of intersection, and since I just bisected a 90-degree angle, I have a 45-degree angle right here, which was what I needed to do to get my problem done. So I'm going to scoot that over a little bit. And now I've got the first one done. There's my 45-degree angle. Let's think about the 60-degree angle. I don't mind giving you a hint on this one, that I want you to do the 75 on your own. For a 60-degree angle, I could easily think about the homework that I had, which actually was classwork, where I constructed an equilateral triangle using that I know how to copy segments. So if I have the length of the segment of one side, I could bring that up and make an arc. And make this arc almost a complete circle if I want. I will put it on the other end, the point on the end of the segment, and make an arc. It's very important to keep that compass opening the same. And then I can connect those two, the end point with the point of intersection. I can go way out here if I want, end point, point of intersection, and I should have a nice 60-degree angle. Looks like this can be adjusted just a little bit. Grab it. And so this should be my 60-degree angle. We can measure it to make sure it's 60 degrees. So I'll do the same thing there. I'll move this down. This is 60 degrees. And now your job is to think about how you can use the things that we've already done to come up with 75 degrees. So I will challenge you to do that, to bring in and share it with the class.